All right, hello everybody. Welcome to your first lecture of Unit 2. This is going to be a lecture all about the periodic table. And I know I've used it before, but there's a lot of information in this thing, it turns out. And we're going to be sort of talking about the various parts and what extra information you can glean from just its shape and how the elements are arranged in it and stuff like that. Okay, so your guided notes for this is just going to be your periodic table of the elements sheet that I've given you. Feel free to color in various regions of the periodic table as I mentioned them, but mainly you should endeavor to make sure you have all these groups at the bottom filled out, all 9 of them. You can color code them if you want, as I said, or just write all of the things that I'm writing on the periodic table as your notes. Okay. Alright, so let's get started. The periodic table, the things that we know about it so far, right, is that it has all of the elements on it. Everything on the periodic table is an element. Nothing on the periodic table is a compound. And we know that it is arranged in order of atomic number. So starts up here with hydrogen at number 1 up there and goes all the way, this is a little outdated actually, it's very outdated, down to 112. I believe we're currently at 119 in terms of elements that have actually been made in a lab. But this is the periodic table that was sort of assigned to as a reference by the state of North Carolina for high school science students. So this is what we're going with still. And beyond that, we know that there are, this bottom number on every element is the atomic mass, 1.008 in the case of hydrogen. And we know that generally speaking, that also increases as you go down the periodic table, although there are some exceptions, and I can show you the sort of major one up here. Iodine down here, 126.90, rather than going, you can see to the right of it, we have xenon, which is at 131.29. That's what you would expect, right? Because things should increase going from left to right and from top to bottom. But over here, tellurium is actually heavier than iodine. So there are some exceptions to that, but the atomic number will always go up. There are no exceptions to that as you're going left to right or top to bottom. Okay, so that's kind of what we know about it so far. Let's talk about a little bit more about why it's, or how it's arranged, the periodic table. First of all, a little bit of nomenclature about the periodic table. It's arranged in sort of a grid, right? So you can speak about rows on the periodic table, things that kind of go this way, and columns, things that go up and down. That was a pretty pathetic up and down, but you get what I mean. On the periodic table, these have special names. Rows are called periods. Okay, this is why it's called the periodic table. And columns are called, they're called a couple things, but mostly they're called groups. Okay, so for example, this column of elements right at the end here with an 18 on top of it over here, that group is called the noble gases. Okay, and we'll get to what all the various groups are called in just a second here. But when I talk about a period, I mean a row. When I talk about a group, I mean a column. Okay? So, let's talk about all these groups. And the sort of regions in the periodic table and what they mean. So the first big distinction you should know about the periodic table is that is what is a metal and what's a non-metal. And finally, we're going to, down here, write what the metalloids are. Oh, sorry about that. I erased my periods and groups there. Okay, so then we'll talk about what the metalloids are. So the metals and nonmetals are kind of labeled as regions up here. The metals are basically on the left side of the periodic table, and the nonmetals are on the right side. The actual dividing line between them is this little staircase looking line right here. Okay? Everything to the left or underneath this line is a metal, and everything to the right of it or above it is a nonmetal. Okay? There are some specific metal or some specific elements that get a special distinction that are called metalloids. For your purposes, you don't really need to know what specific properties they have. It's just that they have some properties of metals and some properties of nonmetals. Okay? There are 7 of them, and we're just going to list them. They're going to be on your notes. You don't really have to care about them more than that. Okay? So, the metalloids are boron, which is B. So that's number 5 up there. They're all touching this staircase line, by the way. Then the next one is silicon, Si. And then we have germanium, Ge. And then arsenic, As. Antimony or antimony, which is Sb, confusingly. Tellurium, which is Te. And then finally, polonium, which is Po. Okay, so those are the 7 metalloids. Just write them down. Don't have to memorize them or anything. Just have them in your notes. All right, and you can see, you know, here's boron up here, and then you've got silicon, arsenic, tellurium, and then on the bottom of the line, polonium, antimony, and germanium. Okay, so they're all touching that little staircase line, but not everything that touches it is a metalloid. Okay, aluminum, you know, you're pretty familiar with that. That's definitely a metal. And I don't even, astatine, not something I'm familiar with. 85 down there, but that is a non-metal. Okay. So that's the first big distinction: metals and non-metals and metalloids. Then we further divide things up into groups, and the groups have names. Okay, I'll say the groups have names. The names of these groups is what we're going to write on the bottom of this sheet. Okay, those little O's down there, we're going to be going from left to right and just writing out the names. Okay, so starting all the way on the left here, we've got this group here. The groups are numbered, by the way, so this is group 1. And group 1 is called the alkali metals. Alkali metals. Not alkaline metals, alkali metals. Okay? Hydrogen is sort of debatably in this group. We don't need to worry about that, but these are very reactive metals that you commonly see in salts, and by themselves they're extremely reactive. You'll recall I talk about sodium as this very reactive, shiny metal. Well, there's sodium right there in the alkali metals. Okay? Next up, a sort of less reactive but still pretty reactive group number 2, right here, has a very similar name. They're called the alkaline. Now, alkaline with the Ne, alkaline earth metals. Okay, so there's lots of things you've heard of in here. Magnesium, calcium, you know, those are fairly common like you need magnesium for the functioning of your body, stuff like that. Those are all both metals. All right. Then we're going to kind of take up a whole bunch of groups. We're going to do this whole region in the middle here. And this whole region is called the transition metals. Okay. Can I write down here? Transition metals. Okay. I'll write it up top here so it's a little more legible. Transition metals. Okay, this is everything in this big block in the middle, and this is where you find a lot of the stuff, a lot of the elements that you sort of consider to be metals, like iron, nickel, copper, zinc, silver, gold, stuff like that. Okay, you can think of it as a transition between the two halves of the periodic table, right? It's this big chunk in the middle, and they're called the transition metals. Okay, then we're getting over to this block over on the, well, I guess looking at my picture in here, it's over on this side of the periodic table. So we skip all of those groups in the middle and go straight to group 13 next. And these groups are all easy to remember because they're just named after, with the exception of the last two, they're named after the element that's at the top. Okay, so group 13 is called the boron group, because boron is at the top of it. And what's next? You guessed it, it's the carbon group. Carbon group. And then we've got the nitrogen group. The carbon, nitrogen, and oxygen groups also have other names. We don't need to worry about those. We'll just stick to the naming convention that makes the most sense. Next is the oxygen group. And then this last group, group 17, over here, this is not called the fluorine group. I mean, you can refer to it as that, but its official name is more important and is used regularly. It's called the halogens. Okay, Halogens, the halogens. And then finally, group 18, our last blank in here, is called the noble gases. Alright, they're called noble because they don't react with anything, and are in that way, I guess, are kind of seen as kind of, I don't know, pristine or important or fancy. So that's where the name comes from. And this is where you have gases like helium and neon that get used a lot because they don't react with anything. Okay. So that's all the groups and all the regions of the periodic table that you will need to know. One just notable thing that I'll just point to, these rows down here, these periods, these are referred to as the lanthanides and actinides, or the inner transition metals. The only thing that we really need to know about these two rows is that they, if you look at the atomic numbers down here, lanthanum 57 goes straight to hafnium 72, and down here in actinium goes from 89 to 104. And you can see these two rows fill in those numbers. So in reality, these two groups kind of get wedged in this little transition here. But you can imagine if we took that group and just put it in there into the periodic table and spread it way out, it would be really hard to read. And so what they've done instead is take that chunk out and put it on the bottom and sort of squish the two sides together. We don't really need to know about why and why those 2 rows only exist in the bottom. If you're curious about that, take chemistry. It's quite interesting. Okay, so last thing, just to complete our table, is that we are going to talk about oxidation numbers. All right, you are not going to know what that really means until the next video, but suffice it to say, when these elements make ionic bonds, they turn into ions. Basically, they donate or accept new electrons, and they become ions, which, remember, those are when the number of electrons are different from the number of protons in an atom. Okay? And basically, the number of electrons that they give up or get depends on where they are in the periodic table. Okay, so just for now, let's just write down our oxidation numbers, and then when we come back to them in the next video, it'll make more sense. All right, so for group 1 makes +1 ions. So its oxidation numbers are +1. Group 2 makes +2 oxidation numbers. So write these down above these two groups. The transition metals, they can make a bunch of different types of ions. This group, the boron group, is still at plus. They make +3 ions. The carbon group generally does not ionize, so we're going to leave that blank. The nitrogen group now makes -3 ions. Oxygen -2. Fluorine -1. And then the noble gases 0. Okay, so again, just for now, write those oxidation numbers down. We'll come back to them, but make sure you get the pluses and minuses right on this. Okay, so that is all for the our first big look at the periodic table, and I will see you guys in class.